All right, for our next topic, we're going to take a look at functions. Now, I know what you're thinking. Mr. Naylor, functions, come on, we've been talking about those for years. Well, it's true. Most things in math are functions, but remember, we're going back to the building blocks of algebra. We're reviewing some main ideas so that we can understand a little bit better before we advance through this second half of the year. So let's start with functions, and probably one of the most common things that we talk about with functions, that would be the domain and its connection to the range. Now, again, you should have heard this before. Each x in the domain, that is every input, is going to be matched with just one y value in the range. That is the output. So each input has one output. I always like to liken this to a soda machine. If you walk up to your favorite soda machine and let's say that you push the button for a Coke, you expect a Coke to pop out. That's because a soda machine is a function. I input Coke, I output an actual Coke bottle. But what if I would push that Coke button, and when I push it, I don't know if I'm going to get a Coke or maybe I'm going to get a Sprite. I input Coke, but I output maybe a Coke, maybe a Sprite. Well, that might be fun for some of you. It might be fun to kind of not know what you're going to get, but that's also not a function. And that type of soda machine would have too many outputs. And so just like that soda machine, math equations typically will have just one output for each input. And of course, when that happens, we would say it's a function. Now, if that doesn't happen, we would say it's not a function. So we have a kind of a standard question here. If I give you an equation, is it a function? Well, let's find out. Let's take a look at an equation. Maybe the equation negative x plus y squared equals 1. Now, that's not just your run-of-the-mill equation. It's a little different looking. We've got x and y on the same side, and of course, y also is being squared. But just think about for a minute with me about some input and output. Let's say I input the number 0. I input that for x. What kind of output, what kind of y value is going to make this equation equal 1? Well, if you think about it, this would be like 0 plus y squared equals 1. And I'm pretty sure that if I input the number 1, I'm pretty sure that one of my y values that would have to work here would be a y value of 1. But wouldn't it also be true that the y value of negative 1 would satisfy this equation? Now, what this is saying is that if I input the number 0, then I can output the number 1. Or if I input the number 0, it looks like that I could output the number negative 1. In other words, for the x value of 0, I have two y values. Well, that's not good. That means that this equation appears to not be a function. Now, you know that we often will use a graphing method to decide if something's a function. Remember, we call it the vertical line test. But if we want to use a graphing method, then we're going to need to be able to solve this equation for y. And if we want to solve this equation for y, we got to be careful about some details. One of those details would be that, of course, we want to move the x to the other side. That means you're going to add x to the other side. The other detail would be that I want to take the square root of both sides. Now remember, when you take the square root in an equation, that creates a plus or minus. And so what this is really saying is that y would equal a plus or a minus square root of x plus 1. Now remember, the reason that we're solving this for y equals is because we want to graph this. And of course, to graph it, we need it to be in y equals form. And we also need Desmos. Now, I encourage you to type this into Desmos, even though I did it for you. Make sure that you're comfortable with a number of things here. First of all, comfortable with the fact that I'm typing in two equations. That's because I have a plus square root and a minus square root. But the good thing with Desmos is I can just type it in as it shows. I can select the plus sign over here. I can select the square root sign, and then we'll just type in x plus 1. And then I'll select the negative sign, which is this minus sign over here, the square root, and then again I'll type in x plus 1. So I'm typing in two equations, and when I type in those two equations, ultimately that graphs for me my plus or minus square root and I end up getting an equation over here that's not a function. In fact, you can see that when x equaled 1, excuse me, let me take another spot here. You can see that when x equaled 0, as it did on our previous example, when x equaled 0, we have two y values. We have a y value of 1 and -1. And of course, that was one reason we just said that this was not a function. But if I continue to draw vertical lines, I can see that it touches at 2 points. And whenever that happens, we would say it fails the vertical line test. And so once again, our equation, -x plus y squared equaled 1, well, that is not a function. How about this equation here, that is y equals the square root of x squared minus 1. Now, I give you this problem because sometimes students will think that anytime there's a square root that it's always plus or minus. No, that's if you take the square root of both sides. But if I have a square root, like in this problem, it's kind of like I've only given you the positive. The reason it's only the positive because that's the way it's given to you. If I wanted to give you the negative, then I would have written a negative sign. Nonetheless, we have an equation that we certainly have the ability to graph. And of course, when we graph it, we want to see if it passes the vertical line test. So once again, we have Desmos. I hope that you have Desmos open. If you don't, make sure you pause the video and open it up because you want to type these in. You can type in the square root of x squared minus 1. Again, you only want to type in a positive square root. This is not a plus or minus problem. And how did it look for you? Here we have the graph. It's actually a two-sided graph. Nonetheless, if you start thinking about vertical lines along this graph, they only touch at 1 point. And over here, they only touch at 1 point. And so even though this equation is a square root equation, it's going to pass the vertical line test. Yes, it's a function. Now, sometimes an equation can't be graphed using Desmos because maybe the equation is just different. Like this one, x equals the absolute value of x plus 2. X equals the absolute value of x plus 2 with a domain of 0, 2, and 4. Now, before you get worked up about the domain, I just made that up. I'm creating this example. So why is the domain 0, 2, and 4? Just because I want it to be. So that what we can do is we can find the range. So we can figure out what the output would be. Now, if I tell you that 0 is in the domain, then I should be able to plug 0 in for x. And when you plug 0 in for x, you're trying to figure out what y has to be. Well, you can do a little thinking here. Basically, it looks like that the only way for this to equal 0 is for y to equal -2. Of course, you want to double check, are there any other y values? But that's the only y value that's going to make this equation, again, equal 0. So when I input 0, I output -2. Okay, honestly, so far so good because I have an input that gives one output. What happens if I input the x value of 2? What happens if I input the x value of 2? Well, we're trying to solve for y, and you can kind of look this over. It looks like y equals 0 is going to get the job done. But what about if y equals, that's right, -4? Now, if y equals -4, I'm going to get the absolute value of -2, which ends up equaling 2. So it looks like here I have two y values, 0, -4, and both of those y values appear to match with the input of 2. Uh-oh. I just pushed Coke on the soda machine, and I might have gotten a 0. I might get a -4. It looks like I'm getting two outputs for that input. Let's see what happens if we plug in 4, our last number in the domain. Now you'll notice I'm plugging in for x. And again, I'm thinking to myself, well, what y value would work here? It looks like a y value of 2. Of course, 2 plus 2 equals 4. What about the negative y value? Are you thinking? That's right, it would be -6 because, of course, -6 plus 2 is -4, but you have to do the absolute value, and that's going to come out to be 4. Once again, it looks like we have an input of 4, but we have an output of either 2 or -6. Okay, now what's happening here is we're coming up with the range. We're coming up with the range. I can put it in little curly braces, but ultimately I want you to see that the way that this equation maps would show that I have too many outputs for each of those inputs. And so we have a nice example of a problem that is not a function. It is not a function, and we didn't need to graph it to find out. We just thought a little bit about the domain and range. All right, are we having fun yet? Remember, this is functions. I like to talk about another idea, evaluating functions. It's something you've done before. Sure, just plugging in for x. I mean, we just did that in the last example. But sometimes we can create a situation that makes you think a little bit more, especially when you see some notation that you understand what it's telling you to do. So here's the function x squared plus 2. And what if I want to evaluate for f of negative 5? Now, you've seen this kind of notation before, but just remember that negative 5 is the x value. And when I plug in negative 5, I want to very carefully make sure that I'm squaring the entire x value. So I'm squaring negative 5, and you shouldn't need a calculator to do that, but remember that that has to come out to be positive 25. And so even if you are using your calculator, make sure you're using it correctly, okay? In other words, make sure you're putting parentheses around that negative 5. All right, so we have a little evaluation problem, and remember, evaluating means that you're plugging in. How about something like this? What if I want to evaluate x plus 5? Well, I'm still plugging in for x, but now I'm going to be plugging in x plus 5. And if you're careful with the way I set up the other problem, you'd be able to once again create some parentheses that are going to end up being squared. Now we're going to do the quantity x plus 5 squared. Now remember, it's a math teacher's nightmare when students say that that equals x squared plus 25. That is a no, no, no. But you can think about the FOIL method. You can think about what it means to square. That is, you can think about x plus 5 times x plus 5 like a little FOIL method. And when you do that, you end up getting x squared, 5x and 5x, which end up to be 10x, and then, of course, 25. Don't forget about the plus 2 at the end, so that we can write this as x squared plus 10x plus 27. Evaluating functions, plugging in for x. But I might add plugging in carefully, especially here when we're squaring either a negative or we're squaring a quantity. One more idea, sort of as we just look at this big idea of functions, and that would be finding the domain. Now, we really haven't found the domain of a problem yet, although we did find the domain of sine, cosine, and tangent back in November, but we haven't found the domain of just a regular function. I want to look at 3 types with you today. One of them is one that's going to have a square root. Now, when you have a square root, what you can do is you can think about numbers that you're allowed to use. And numbers that are allowed to be used are going to be such that when you're under the square root, that will come out positive. Sounds a little fancy. Let's actually do it for a couple problems. Remember, if we have a square root, like maybe the function f of x equals the square root of 4 minus 2x, and we want to think about numbers we're allowed to plug in here, it's as simple as saying that whatever is under the square root, that is the 4 minus 2x, has to be greater than or equal to 0. Now remember, that's because you can't take the square root of a negative number, but I can take the square root of a number that's greater than or equal to 0. Sometimes students think that we're just kind of making things up, but what we're doing is we're interpreting the square root, which means that what's under the square root, that is 4 minus 2x, has to be greater than or equal to 0. Now I got myself a little problem to solve, and, solve it using some good algebra. Subtract 4, divide by negative 2. Let's show this so we can get this correct here. Again, divide by negative 2. And it looks like we're going to get x, and we're going to get 2. Now I'm pausing because do you remember whenever you divide by a negative, it makes something change. That's right, you have to flip that greater than sign to be a less than sign. So really we're saying that the domain has to be less than or equal to 2. Okay, when you have a square root, whatever's under the square root has to be greater than 0. Okay, does it work all the time? Yeah, it works all the time as long as you have a square root. Okay, like this function, which kind of purposely, oops, let me write this a little differently, which kind of purposely doesn't look like it has a square root, not until I think about solving it. Okay, solving it for y equals, which you can do. You can add 4, and, well, you can take the square root of both sides. Now, we just got done talking that whenever you take the square root of both sides, you always get plus or minus, so we should write that correctly as plus or minus the square root of x plus 4. Okay, now, the reason I'm going over this problem is so that we can once again say that whatever is under the square root has to be greater than or equal to 0. Well, x plus 4 is what's under the square root. You mean that has to be what's greater than or equal to 0? Yeah. What about this plus or minus that we made out here? Well, it turns out that that's not under the square root, so it's not really part of the domain. You might say it doesn't really matter. But what does matter is that I subtract 4 from both sides, and I get x greater than negative 4. You don't have to flip the sign. You didn't divide by a negative number. Finding the domain, thinking about numbers that you can use. Finding the domain, thinking about numbers that you see on a graph, particularly the x numbers. And as you look at that, you want to kind of think about where the graph starts. And since it's a domain, you want to think about a horizontal direction. Okay, now let's do a problem that's kind of fresh and new. How about the square root of 9 minus x squared? Now you might say, well, Ms. Naylor, why is such the focus on the square roots? Well, because I find that sometimes students get confused. Again, here's a square root. It's not plus or minus. It started as a square root. That means it started as positive because that's the way I gave it to you. If we're going to find the domain with a graphing method, then you need to graph this. So do you have Desmos open? Go ahead and type it in. What's it look like? I'm waiting. Type that in, the square root of 9 minus x squared. Pause the video. All right, and how'd you do? Whoops. Not the right graph. Let me skip forward here. There we go. 9 minus the square root of 9 minus x squared. You actually end up with a semicircle. You end up with half a circle. Now, if you're thinking about the domain of this circle, as it says over here, we can pick like a starting point. I feel like that we have a point here where the graph starts, and maybe we could even argue over here is kind of where the graph ends. Honestly, you don't have to focus on this point up here. That doesn't have anything to do with the x value, starting or stopping. But I really just need to think about how far we're going from point A to point B. And it looks like we're going from -3 to 3. So my domain is going to be between -3 and 3. And I can write that answer using interval notation if I want to, or I could write that answer using inequality notation, in this case, a compound inequality. All right, so looking at a graph, thinking about like its starting value, in this case, even its ending value. Now, let me make sure that we see this other example, and it was supposed to be -3x squared plus 4x plus 5. Again, we have an equation. We're trying to think about its domain. Yes, we're going to graph it. Yes, we're going to look at the x values. But I just kind of want you to think for a second before we do that. What x values are you allowed to plug into this equation? You say, what do you mean I'm allowed to plug in? Well, could you plug in negative numbers? Sure, you're allowed to square negative numbers. Could I plug in 0? I think so. Could you plug in positive numbers? It looks like that I could plug any number into this equation, there's no restrictions. Well, it turns out that when you see the graph of negative 3x squared plus 4x plus 5, you can make the same conclusion. Now remember, when you see these graphs, there are arrows on the end, and you have to think about what these arrows are doing. Yes, they're going down, but we're not looking at this graph vertically. We're looking at this graph horizontally. And horizontally, you would say this graph continues to open to the left and continues to open to the right. And as the graph opens to the left and to the right forever, we're going to end up with the same thing that we said, negative infinity to infinity. Domain, thinking about numbers that we see on a graph. One last domain, at least one last way to think about a domain, would be actually the numbers that you can't use. Now, numbers that you can't use typically have to do with denominators and denominators equaling 0. And so when a denominator is equal to 0, we have a problem. Okay, we have a number that you can't use. How about the equation 1 over x squared minus 8? Okay, it's clearly a fraction, clearly has a denominator. And so what we're going to do is we're going to say that this denominator is not allowed to equal 0. You see, what I'm doing here is I'm once again interpreting the equation. And as I interpret it, I'm able to solve it. And as I solve it, I'm actually describing the numbers that are not in the domain. Now, were you thinking that you were going to have to take the square root of 8? You're right. Were you thinking that you get a plus or minus? I hope you were. And we end up saying that x cannot equal plus or minus. Now remember, the square root of 8 is actually the same as the square root of 4 times 2. And I hope that you're going to pull that 2 out. I'm sorry, you're going to pull the 4 out as a 2. And then you're going to leave that other 2 behind. So we get plus or minus 2 root 2. Now technically, the domain would be all numbers that are not equal to plus or minus 2 root 2. That means every other number is fine. You just can't equal 2 root 2. Let's do one more problem that involves a fraction. And we're going to simplify things a little bit. Okay, because what I want to make sure you understand is that it only has to do with the denominator. In fact, oh, wait, I copied this wrong. I wanted this to be x plus 3 over x plus 5. Now, again, the reason that I'm giving you this problem is because we want to be able to say again that it only has to do with the denominator. So it's only x plus 5 that can't equal 0. That means that x is not going to equal negative 5. How about the numerator up here? Well, how about it? It looks nice. It's pretty, but it has nothing to do with the domain, okay? Because the domain is only restricted by a 0 in the denominator.
Dad.
What?
Are you listening? Did you see what happened?
No.
Boston Scott, the backup running back, 60 yards to the house. We started at the 19-yard line, and we got all the yards off of rushing. Sanders for 30, then Scott for 60.
All right, we need to hurry up and finish this lesson so I can get upstairs and watch that Eagles game. Let's go!